Hello, my name is Lillian Schmitz. The date is February 21st of 2021. Today we'll be going over the integumentary system. On the back of my note card here, I just have some notes to follow along with for this presentation. So like I said, we're talking about the integumentary system. The integumentary system is comprised of the skin and its derivatives, which include the hair, the nails, sebaceous glands, and sweat glands. So we're going to go over the layers of the skin. So your top layer of your skin is your epidermis. That's the layer that we see. The epidermis consists of stratified squamous epithelial cells, as well as keratinocytes, melanocytes, Merkel cells, and Langerhans cells. So your skin is composed of 5 layers. So the epidermis is composed of 5 layers. The first layer is going to be the stratum corneum. This is a layer that is about 20 to 30 cells thick. They're all dead cells, and below that you're going to have the stratum lucidum, and this layer is only in thick skin. That is skin on your palms of your hands and the soles of your feet. Thin skin only has 4 layers. It does not have the stratum lucidum, and that is the skin that is elsewhere on your body. Below the stratum lucidum, you have the stratum granulosum. This is the cell's last stop before they essentially die. Below that, you have the stratum spinulosum. These cells are said to look spiny, hence the name. That comes from them keratinizing, which causes them to get that spiny appearance. Below that is the stratum basale. The stratum basale is the base layer. It's the bottom layer of the epidermis. This is where all new cells are made. It's a highly mitotic region. So any cells in your epidermis started in the stratum basale. They all were there at one point. So then below the epidermis is your dermis. And in your dermis, you have 2 layers. You have your papillary layer, which is the superficial layer. This layer has dermal papillae, which create epidermal ridges, and those are your fingerprints. Below that, you are going to have your reticular layer. Your reticular layer is mostly dense, irregular connective tissue. It's mostly collagen and elastin fibers. Cool thing about it is those collagen fibers actually run parallel to the skin and make cleavage lines, which surgeons use when making an incision. It allows if they cut along a cleavage line, the incision will heal better than if it is cut against a cleavage line. So then you have the subcutaneous layer below the dermis. So this is the final layer, and some consider it not to be part of the skin, but the main thing that makes the subcutaneous layer is adipose tissue. So it mainly stores energy. It also insulates the body and protects underlying structures. And it also actually attaches to the underlying structure, which is usually muscle. Then we have our accessory structures of the integumentary system. So that's going to be your hair, which I guess we'll just focus on. We've got the root of your hair. That's where the cells are still being made, and then you've got your shaft, which is what you see, and the shaft is just dead keratinized cells. So basically everything that you see on your body is dead, which is crazy, but then you've got your sebaceous glands. Those actually are attached to most of your hair follicles, and they release sebum, which is a oily substance that moisturizes your skin and hair. You've also got your sweat glands, which include your apocrine and your eccrine sweat glands. So your eccrine sweat glands are going to be the ones that are just all over your body. What they release is just kind of mostly water, salts, and metabolic wastes. And then your apocrine sweat glands are going to be sweat glands that are under your armpits, as well as in your genital regions. And these release more of like a viscous material, and this is going to be the smelly material too that you think of when you associate it with body odor, and that is actually just the bacteria breaking down sweat. But that's your apocrine glands. Those also include mammary glands and the stuff that makes earwax. So pretty cool. But good clinical application. Oh, and nails. Oh my gosh. So then you have your fingernails. These are just keratinized regions of your skin, and they serve to protect your digits. So a good clinical application for the anatomy of the skin is going to be So since I work in veterinary medicine and I plan to be a veterinarian, one thing that a lot of veterinarians will do is a skin scraping or a hair pluck. The one I'm going to focus on is a hair pluck. So a hair pluck is where you take a hemostat and you pull about 10 to 20 hairs out of an animal. It's usually pretty painless, so it's a preferred method if you can use this to diagnose or treat a disorder. So what we'll do is then you put mineral oil on a slide and then you will view the hair under the microscope. And the only way to know if anything is wrong is to know what it's supposed to look like if things are right. And so that is why skin anatomy is very important in medical professions and as well as veterinary. So yeah, thanks for listening. Bye.